Okay, now I'm going to show you how you can adopt the previous method we just talked about, that method of sort of taking little teeny determinants and making a big matrix, then taking a flip along the diagonal, and then dividing that by the scalar of 1 over the determinant to actually get the inverse. It's a big old mess, but it turns out it actually works. Let's take a look at an example together. Suppose the matrix A, which in fact is a 3 by 3 matrix, looks like this. 1, 0, 1. 2, minus 2, minus 1, 3, 0, 0. And my goal is to find the inverse of this matrix. What is that? That's going to be another 3 by 3 matrix that has the property, if I matrix multiply the inverse by this, I should get the identity. That's the matrix that has 1s along the diagonal and 0s everywhere else. Okay, so how do I proceed? Well, the first thing I actually have to do is find the determinant of this matrix, because I have to have 1 over the determinant way out in front of my new matrix. So let's just make a little side calculation. So first, find the determinant. So what's the determinant? Well, let's give it a shot, shall we? I'll expand around here. And remember how this goes. Finding the determinant, I take this term and I write it down. I multiply that by the determinant of what I have left. But notice the determinant of that is 0, because it's 0 minus 0. So in fact, that's easy. That's good. That's 0. Then remember the signs. I've got a plus minus here, so I take a minus. 0 times, well, this determinant. Well, that determinant turns out to be actually 3. But since this is a 0, who cares? But I'll write it anyway. And then plus minus plus, so this would be a plus 1 times, and what's the determinant of when this is all taken away? Well, you can see this is going to be a 0 and then minus 6, so it just becomes 6. So in fact, I see that the determinant of this matrix is 6. So the determinant of this matrix, I'll write that down, we computed to be 6. So the inverse, we're going to start off by dividing by 6. So we'll have a 1/6 scalar in front. Okay, that's just a little calculation that we'll need for later. Now, how do I proceed? Well, now I'm going to make this new matrix, which I call N. And it's going to be sort of made in the similar way as we computed the determinant, but this is going to be a little teeny bit different. So remember how this goes. If I want to find out what goes in this spot, I go to the analogous spot here, and I block that off, and I see the matrix that's left and take its determinant and write that number right in here. I don't multiply by that value like you do when finding the determinant of the whole matrix, like I just did. This is now something special. I'm building a new matrix, and the entry here is just the determinant of this thing right there. So I put that in, and what do I see? Well, I see a 0, 0, so I just see 0. Now to find this entry, I just go to that analogous entry there, block off those people, and take the determinant and put that answer in here. Here I see a 0 and a minus 3, which is a 3. I do the same thing here. I come here, block off the analogous spot here, see what's left, take the determinant. This would be 0 minus 6, which would be 6. But now I've got to keep going. To find out what spot goes here, I just block the analogous spot off here, which would be this. See what's left and take a determinant. In this case, I'd see 0, 0, so I see 0. What about this middle one? That's sort of harder to do, but there it is. The middle one would be a 0 minus 3. And that last one, I just blocked the analogous spot off here. Whoops. And I'd see a 0, 0. See how I'm making a new 3 by 3 matrix? And all I'm doing is I'm taking these little minor determinants. In fact, these are actually called minors, in fact, but who cares? What about what goes here? What do? I just block off the analogous thing here, take a determinant. This would be a 0 minus 2, which is 2. What about here? I just block off that spot, analogous spot. I see minus 1 minus 2 is minus 3. And then what about that last spot? I block off that last spot, and I see negative 2 plus 0. So I see negative 2. So there's the new matrix. However, remember I've got to put in the sign chart thing like we did before. So I've got to put in a plus, minus, plus, and then I do the opposite here. So minus, plus, so this doesn't change, minus. And then here I put in a plus, minus, and then a plus. So notice that some of the signs do change, and what I see now is the following. My new matrix, if I write this out nice and neat, looks like this. I see 0, I see minus 3, I see 6, I see 0, minus 3, 0, 2, and then a minus 3 is actually just 3, minus 2. So some of those signs actually changed when I put in the plus, minus, and so on. Okay, now that's the new matrix. To find the inverse, here's what you do. So A inverse, so the inverse of this original matrix, is 1 over the determinant. So you take 1 over the determinant, which we computed earlier. So that's 1 over 6. And then here, what you do is you take the new matrix we have and you just flip it over this line. So let's do that. The diagonal elements will actually stay the same. So I'll just have this 0, minus 3, and minus 2. But then this term and this term and this term flip. So I put the 2 way up here, and I put the 6 way down here. And then these two terms flip. So I have a minus 3 and a 0 here. And these two terms flip, and I see a 3 and a 0 here. Phew! Well, it turns out that that actually is the inverse. And you can multiply everything through by a 6th, which means I would just see 0, 0, 2 6, minus 3 6, minus 3 6, 3 6, 6 over 6, 0, and minus 2. So in fact, I guess I could write that like this. I could say the inverse equals 0, 0, and 2 6 is just another way of saying 1/3. And minus 3 over 6 is just minus a half. And then I see another minus a half. And then I see just a half. And here I see a 1. Here I see a 0. And here I see a minus a third. And you can check this. It turns out if you take this matrix and multiply it by this matrix, what you would see everywhere is going to be the diagonal identity matrix. If you multiply these two things together, you'll just see 1, 1, 1, and then zeros everywhere else. You'll see the identity. And you can try that if you want. The method, though, was a little bit elaborate, but actually it's about as easy as it gets. You first find the determinant very carefully, and then you find this new matrix, which is a little bit tricky. To find the new matrix, what you do is you, first of all, block off people and just see what those minor determinants are and write those minor determinants in the appropriate spots. You then put the plus-minus grid in and change signs where appropriate. Then flip along this diagonal, put that matrix here, and in front, scalar multiply it by the reciprocal of the determinant, and you've got the inverse. And in fact, this, by the way, works no matter how big of a dimension you have. So if you have a 4 by 4 matrix, you can actually now find the inverse of that. But boy, I hope that no one would be so mean to actually have you do that. By the way, one last comment. A really easy way of finding determinants, even easier than this, is to use a computer or calculator. They actually give them to you for free. Anyway, try these, work through them carefully and slowly, and you can get them. You can.